So I will be talking about the technical implementation that we did at Ericsson as part of this project. And so let me start with this connected beehives that we have at Ericsson. I'm not sure even with Ericsson employees know that, but we have these, if you see the left image, there is the big beehive, which is provided by the facilities, CBRE. So they are the ones who have built this beehive, and we see that bees come over and they can do, make honey. So what we did with the Kista Innovation Park is that we came up with this project where we host interns and master thesis students to do some AI and IoT related applications. So we built the next two stands that you see here. So we equipped them with communication services along with some sensors to understand how the ecosystem around us is behaving. So we know that bees are very important for pollination and thus for the food production for the world. So it's important to understand how they behave and whether we have enough flora around and how they help us to impact the society. So on the right-hand side, you see this close-up of the two stands that we have. So we have a camera at the entrance, which is sort of hidden there. And then we have the different modules. So Sasha was kind enough to build this in a modular format so that you can just replicate the solution for any number of Ericsson buildings that we have. So this is set up on the terrace of building 8, which is behind us currently. Then, so to understand more about the bees, we feel that they are the perfect examples of biomonitors. Like I explained, they're very important for the ecosystem. And since they forage over wide areas, they accumulate a lot of trace pollutants and provide spatially resolved data on this contamination that is available in the environment. So as I mentioned before, we have equipped this connected beehive with a bunch of sensors. So we try to monitor the temperature, the humidity. We also try to see the weight of the beehive, which helps us to understand whether the bees are thriving or not. And it also helps us to understand what is the lifespan that they have over a period of time. So it really helped us to understand a lot of important details. And we also do the monitoring of the sound, and we look at the video. As you see in this picture here, this particular bee is infected with varroa mite, which is basically harmful for them. It helps us to understand whether they are infected if there are more pollutants or some other unwanted aspects of species in the environment. And we also try to understand from the cameras that we can also analyze the pollen that they bring in from the different areas. So this was like a perfect example to understand how they can act as biomonitors. And thus we also have integrated this particular aspect or the solution into the tool, which Anton just gave a nice overview of. So we have built a simple dashboard, which basically monitors the temperatures in and around the beehive. We monitor the weight, we look at the temperature, we look at the weight of the honey that was produced. And as you can see here, the camera basically does this image detection and understands to see if they are carrying what kind of pollen and sort of things like that. So this was a very interesting project that was done last year, and it is still ongoing. And when we looked at the current, when we looked at it this year, the beginning of this year, it was pretty slow business because it was still cold during spring. But we observed after a month that the bees started coming in. So it was very interesting to know that, okay, they thrive during these months, and what happens during the months when they are pretty dormant. So it was very, a very important aspect that we learned in this project. And to show how we integrated this particular aspect into the tool, before that, I would like to highlight and show that the bee that you see here as the point of contact here, you see it's on the terrace of building 8. The next to it is building 9 and 10. And the blue part, which you see, that is the Kista Innovation Park. This is important to understand because the parking aspect that I will explain later is very important to look at how the surrounding is. And then the big 2 parking lots that Anton also mentioned, which we try to monitor. So those are the 2 big parking lots. And just to show a video of how this particular application was integrated into the tool. So we have a look at it's possible for us to stream the data that we get from our application into the digital twin application itself. Yes, and then this particular object is a biomonitor object, like Anton explained. So it was pretty interesting. We liked the picture, and that's was the point of contact. Okay, so So this is the most important aspect that we did in this project since last year, and we wanted to understand the how the parking pattern occurs in Kista, where we are situated. So we have a number of Ericsson buildings, and it was important for us as well to understand how parking is being used and whether it is sufficient for the employees around in the different buildings that we have in Kista. And we also conduct a bunch of user testing meetings with the real estate owners in Kista, and they were very kind to tell us some of the important pain points that they are encountering. And parking came as a huge and a recurring problem, and so thus we thought, okay, let's do something about it. And so this particular slide gives you a timeline of the different aspects that we undertook in order to come up with what all the things that we learned in this project. So the beginning, as Anton mentioned, we are trying to look at the big parking lot from the Kista Science Tower. So this is the setup that we have. We have this Raspberry Pi and bunch of small D-Link cameras. We get the data from these sensors, and then we basically upload it to our database. And we try to observe what is the usage of that particular parking lot. So what we did was, it was not feasible to go and count the cars in the parking lot every day. So we thought of taking pictures of it. So we managed to get a good set of data for 1 week. And we started applying AI on top of it to understand what is the occupancy of both the parking lots. So if you see the first picture, we have the cropped version of the big picture that we took from the Raspberry Pi. And then we tried to remove the buildings, and then we tried to apply the models. And this is what we observed. And this model was not working that well because it was not accurate. It was very difficult to fine-tune this model. So we thought of doing something else, and we started looking inward. So we thought, okay, let's start with small setup. So what we did was, we went and we looked at the parking space that we have next to the Kista Innovation Park. So this was very close for us as well. But before that, we tried a lot to get some permission to monitor the big parking lot from the Ericsson buildings, like the building 8, 9, and 10. But then it was very difficult because we have labs there, and it's basically sort of a security problem as well. So we thought, okay, let's do something with the existing setup that we have. So if you remember the B story there, we have the B setup there. So we use the same setup and built using the I can show you the picture in the next one. So what we did was, we took the same setup, which is the modular setup from the Beehive, and planted this similar Raspberry Pi and camera, and also powered the Raspberry Pi with a solar panel, and enclosed that in a box, and we planted just one camera on top of building 8, which is a bit away from the Beehive actually. So this gave us a better view of the parking lot, and it also helped us to build a better AI model. Even then, it was not that easy because there would also be problems. Like, say, for example, when it rains, if you see the picture on the right-hand side, top side, you will see that when it rains, the camera becomes foggy, and it's not that clear, and it's very difficult for the models to understand how it works. So, and also we had to plot the entire parking area and also mark those different places so that the model will be able to understand and identify exactly if the parking space is occupied or not. So it underwent a lot of sequence of trials and errors, and then we finally were able to get the accuracy that we wanted. Next up, so what we did was, we took this solution and we shared it in the internal social platform that we have at Ericsson. And we did not know that before, but the employees were so excited after looking at this application that they were like, when are you going to do this for the big parking lot? So we really felt the need for how can we replicate this solution for other parking lot as well. And it seems they have this issue where they have to go into the parking lot, they have to see each and every lane to see whether they are full or not, because there's no other way that they can find if there's a space for them. So it results in a lot of amount of time wastage. So they were very excited, and they said, when are we going to get this dashboard into our internal social platform so they could use every day and not waste time finding which parking lot has space for them to park their cars today. Then what happened was, since we got a good feedback from internal, We also got contacted by our local, our own facilities, and they said that we want to replicate this process for the internal parking that we have, as well as for the big parking lots. So even as we speak, we are in the process of installing more cameras and getting more data and building these dashboards for the employees internally. So it has created sort of an impact, and it was really nice to see that this particular project was basically to understand how cities need space and what planning needs to be done, because we understand from the different stakeholders that it's very expensive and we must make use of the available resources better. So that was very fulfilling, and we felt that, okay, we must do this for other parking lots as well. So thus, if you see here, we have other buildings. We have building number 4 and 5. So we have installed the cameras there, and we also integrate this data to the digital twin tool that we demoed earlier. We will look at the video now. So this is how we have integrated data that we get from our dashboard into the digital twin tool. So this is the dashboard area, and when we click on the camera link there, you can that's here. So if you see the timeline, we have tried to demonstrate the traffic over a period of week. So we are looking at the traffic starting on Monday at 10 o'clock. So Monday, Tuesday, Wednesday, Thursday, and this is on one of the weekend. It's on Saturday. And then we move on to see what happens in the evening. So we choose a time around 5 o'clock in the evening. So this is on a Saturday. We go back. Yeah. So we see the usage, and we see that there are many cars which have left. So thus you can see when you send these data to different stakeholders, it becomes easier for them to do proper planning and also allocate resources according to the needs of the city. So yeah. Okay, to wrap up then, just to highlight the benefits of doing this parking management, right? So it helps us to get this real-time visibility and automation for municipalities, airports, and campuses. It also helps different, to understand what is the short-term parking activity that they must undertake, and for the operators to do this compliance checks, because you do not need to have these manual cars going around and checking whether they have done the parking ticket or not. So all those things can also be automated. And similarly, safety aspects, because if there is an accident, then it also helps us to understand where the problem was and how can we have someone accountable for that. And it also helps the planners to reduce the congestion as well as improve the air quality. And integrated communication networks help with understanding and bringing all these different stakeholders together and to do proper planning. So the impact is definitely huge. So it also helps to do this congestion reduction and optimizing the existing resources. So that's how and what we learned from this entire process, and we hope to continue. And we hope that we can replicate this for different Ericsson offices as well, and as well as for other corporates that are in Kista area. So yeah, thank you. Thank you so much.